Good morning to everyone. I will discuss here the research activity in the year 2025 of the research group of macroscopic quantum phenomena, which belongs to the more general group of condensed matter theory. And the macroscopic quantum phenomena are phenomena where a macroscopic number of particles, or in some cases of pairs of particles, occupy the single particle or two-particle quantum state. So you have a large number of particles in the same single particle quantum state. This is typical of Bose-Einstein condensation. Actually, it's somehow the definition of Bose-Einstein condensation, and that is indeed the main macroscopic quantum phenomena. However, related to the Bose-Einstein condensation, there are other macroscopic quantum phenomena that I have written here. The superfluidity, where at sufficiently low temperature, some fluids show the absence of viscosity. The superconductivity, where again below a critical temperature, some materials show the absence of resistivity, and also the laser light, where under some specific condition, a light beam becomes fully coherent, namely a laser beam, because indeed the photons of this laser beam have all the same frequency and the same linear momentum. Namely, the beam is truly monochromatic and collimated. These macroscopic quantum phenomena can happen at the thermal equilibrium, in particular the first three that I have written here, or also out of equilibrium, specifically in the case of the laser light. The research topics of our group are all of them related to what I was discussing, namely the Bose-Einstein condensation, in particular with atomic quantum gassing, and using the formalism of quantum field theory. The BC-SBC crossover, which correspond to the fact that if you have fermions weakly attracting, they could give rise to superfluidity or superconductivity. But if you increase the attraction among them, they will form truly bound states, and in this case, you reach the Bose-Einstein condensation regime. This phenomenon is strictly related to the properties of some ITC superconductors. The ITC superconductors are superconductors at a high critical temperature, where the theoretical explanation of their property is still in full generality missing. In our group, we study also the quantized vortices and solitons in all the systems previously described, namely in Bose-Einstein condensate, in superfluids, in superconductors, and in laser light. And it's amazing that there is a unique framework to describe them. I am also very interested in macroscopic quantum tunneling with Josephson junction. Josephson junction usually are made of two superconductors separated by a thin insulator, which create a barrier. However, the atomic Josephson junction can be done by a gas or atoms that is trapped in a double well potential induced by an external optical or magnetic field. And the tunneling is macroscopic because it involves the coherent tunneling of a large amount of particles from one side to the other. And another topic that I like a lot is quantum physics in curved geometries and also in two-dimensional or one-dimensional systems. I have obtained an interesting and quite cited result in recent years on this topic. And finally, I am also very interested in quantum field theory of laser light in optical cavities and more generally in nonlinear media. Because the quantum electrodynamics is usually studied in the vacuum, but if you study it quantum mechanically with the field theory in a medium, there are many subtleties and the framework is not yet fully defined. The methods I use are the one of theoretical and mathematical physics, namely quantum field theory, but also Feynman path integrals. In particular, I am teaching the course of theory strongly correlated system in the Master of Physics, which is devoted to the analysis of path integrals for particles and fields describing bosons and fermions in non-relativistic framework at finite temperature also. I like also a lot quantized vortices, topological matter, and solitons. My research activity uses a lot the tools of quantum statistical mechanics, where phase transition are truly very important, and also the physics of low dimensions, which is an hot topic of research today. The main scientific results of the group in the last year are remarkable. We have an average of 8 scientific papers per year. The papers are sometimes published in very prestigious journals, among them Nature, Review Physics, Physics Report, and Physical Review Letters. We usually gave invited talk at many international conferences and schools, and here you see some examples of the papers we have written in the last years. The characteristics of our group are the following. Okay, for sure, there is a direct interaction with the principal investigators, namely me, without the mediation of collaborators. I don't like that postdoc or PhD student are interacting with a master student directly, or they can also interact among them. However, I prefer to follow the research activity of directly of the younger. There are in our group there are no annoying weekly group meetings, differently with respect to other groups. We have a friendly and respectful environment. We have a large vector network of international collaborators, which could be useful for doing a PhD or a postdoc. I want to stress there is no competition about between, say, among the group members. There is instead strong competition with with others outside Padova, with the aim of being always at the edge of the knowledge. We have active collaboration also with experimental groups because from my point of view, theory is important. I'm doing theory, but the comparison with the experiment is crucial. Yeah, here some contacts if you want to interact with me, and some information. The research group is informally made by me, two associate professor, one visiting professor, 3 PhD students, and some master and bachelor students. And finally, there is a remark because there are specific fellowship for doing a PhD here at the University of Padua with the project Quantum Frontiers, and I am strongly involved on that. Thanks a lot for your attention.